Example of some notation we'll be using before we jump into the problem. You can think of capital D not as differentiation, but as the domain operator, or it finds the domain of input function. Okay, so let's pick square root of x minus 3. Okay, we're supposed to return the domain of the function, the square root of x minus 3. All right, and of course, we know if this is a real valued function, we know that x minus 3 has to be greater than or equal to 0. And of course, that leads to the closed interval 3 to infinity. The square root of 0 is 0, right? So there we go. Now notice y'all we have to put parens because infinity is just unboundedness. It's not a number. Now another way to write this that a lot of folks prefer probably is 3 is less than or equal to. And I'm going to minus the set builder brackets here, like this. This is a little more explicit, and I think people like seeing this, but it takes more time to write it down also. Okay. Now, so what we're doing right here is we're given a function f, and the only thing we know about this function that's abstractly stated is that it's has a domain 0 to 1, and you have no idea what the range is. Like I couldn't tell you what f at 1/2 is, what f at 0.1 is, what f at 0.8 is. We just know its domain is between 0 and 1. Now we're going to write down, this is what I would call a definition. The domain of y, and here is y right over here, right up here, excuse me. The domain of y is just the intersection of the two individual domains of the function. Okay, of both functions, excuse me. All right. Now, one way to handle this, which is actually quite easy, the graph is a graph. A well-sketched graph is a function if it passes the vertical line test, right? And so if we can just the very familiar shape of any exponential function, including e, you know, it's you're going to pass through 0, 1, right? You're going to pass through 0, 1 because anything raised to the 0 power is equal to 1. So that's the point 0, 1. We also know that e to the x is always positive. So here is rough sketch of e to the x, and it looks roughly the same for any exponential as long as the base is greater than 1. It'd be reflected about the y-axis if it was between 0 and 1. But so anyway, there you go. So we know that for this to occur, for e to the x to be trapped between 0 and 1, that means we're on the interval minus infinity to 0, which is what we have right here. Okay, and that's all just straight from the graph, which is something all of us can do by hand. Okay, so that's that. All right, so we've just done this piece right here. We know that the domain of this piece right here is minus infinity to 0. Okay. Oh, good, I got the picture drawn. Now, in a similar fashion, we set ln of x, ln of absolute value of x between 0 and 1, just like we did right up here with e to the x, right? Again, because this abstract function, it has a domain between 0 and 1. All right, and so let me, I left out some stuff here. Let's see, this right here is minus e. This point right here would be minus e, comma 1. You'll notice this is kind of an interesting thing. To the right here, this is just ln of x, right? This would be 1, 0 right here, right? Let me see if I can squeeze that in there. 1, 0 is on the graph of any logarithm function that's unshifted, right? That's because any base raised to the 0 power is equal to 1, right? And of course, this would be minus 1, 0 right over here. Okay. And so you see, we can see very quickly what's going on. I mean, we're stuck between 0 and 1, right? And so we get these two statements. We're stuck between these two. In other words, we have this for the left-hand side and this for the right-hand side of this natural log of absolute value of x. Again, the absolute value has the effect of creating an even function. Okay, an even function, which this is. This is an even function that has symmetry about the y-axis. Now notice that this interval right here is the only interval that's contained in both of the, this is the domain of the ln x function, right? This is the domain of the e to the x function when f is applied to it, right? And so this interval is contained in this interval, but this isn't. So that leads us to conclude the answer to the question is minus e to the minus 1. You'll notice that, well, I don't even know if I said this. This is from a JEE test prep book. Some people call it the black book. It's just this very voluminous book to help people prepare for this JEE examination. I think it's an engineering prep sort of thing, but in any event, it's in India, and Americans could learn a lot. The book is just far more in depth in terms of breadth. I mean, breadth and depth. It has a lot of topics and a lot of depth and a lot of abstract problems that you don't see in American textbooks. But anyway, I enjoyed this problem a lot, and I hope you did too.